Okay, I'm just going to do this one question I think that some people might have found pretty challenging, and it was all in a way because of the wording. And they were trying to make you really think, but I think they made it kind of a little tricky, but too tricky. But because this wording, calculate the equation of H, a line perpendicular to F, this parabola here passing through -3 and 0, perpendicular to the point at -3. Well, the only way we can make sense of this, when I think of perpendicular, I think of lines. And what other line could there be there? It must be a tangent line at -3. In fact, that's really what you've got to do. You've got to find the tangent line at -3. And then if you've got that tangent line, you won't have any trouble finding the perpendicular, because you remember what to do. If you've got one gradient, you just turn it upside down and change the sign, and you'll have the perpendicular gradient. So anyways, one thing that's not so nice about this question as well is if you didn't get the first parts right, what A, B, and C are, if you've got like it turns out that the A is -1, B is -1, and C is 6. So if you want to find a tangent line, you've got to find the gradient. And how do you find gradients? Well, it's the derivative. So you go 2 times -1, -2x, and there's your -1. You take the derivative of the function, and then you put in -3, and you'll get the gradient right at -3. Plus 6 -1, there's the gradient at -3. And the perpendicular is, instead of 5/1, it's 1/5, -1/5, though. There's the gradient of that perpendicular, that blue line. And all we know that that's rated 0. So we just put -3 and 0 into the point gradient form of the line, and you get your equation. The equation of the perpendicular line to the function at -3. And there you go. Little bit. I didn't like the wording. A lot of you, if you were thinking about perpendiculars to tangents, then you'd be okay with it. Okay, that's that question.